Okay. Suppose that the angle between A and B is theta. Then the value of cosine theta is the inner product of A and B divided by the product of their length. Okay, or you can call norm, N-O-R-M. All right. So if A vector A is A1, A2, all the way to AN, B is B1, B2, all the way to Bn, both are n-dimensional, then the inner product is the upper term. And the norm is the upper left, norm of A. And upper right, lower left is the norm of A. And lower right is the norm or the length of B. Okay, so that's the cosine theta. But this is not what I wanted to introduce to you. What I want to introduce to you is something having much to do with statistics. So we need something else. Yeah. And this is how the formula is obtained. This is how the formula is obtained, but I'm not going to waste too much time in it. We just apply it, okay? All you need to do is to apply it. And consider any two vectors in A and B, a measure of the similarity in their orientation, their direction of similarity in their orientation between A and B, called cosine similarity, is given by this. The same formula. Yeah. So where theta is the angle between A and B. Okay, theta is the angle between the two vectors, vector A and vector B. Number two. Okay, this is the norm or the length of A, and this is the length of B. Are the norms or length of A and B respectively. And number three, hey, the bracket with A and B. A comma B within the bracket denotes the inner product of the two vectors. The inner product. And you know inner product? Inner product is the upper term. The upper term here, inner product. Here. The upper term here is inner product. Okay? Any question? If you don't have any question, then I will proceed, and I will teach you how to use the measure, use this measure. So this is the inner product of A and B. Okay. Number one, when theta is very close to 0, because this means that the orientation of A and B are becoming the same. Okay, when theta approach 0 degree, hey, yeah, here, that's the vector. Okay, and so is this a vector, a smaller one. Okay, if their angle approaching 0, this means that the orientation of A and B, this is A and this is B, are becoming the same. Their orientation means direction. Okay, they are pointing to the same direction, right? And theta, the cosine of theta is 0 degree, and the cosine 0 is equal to 1. Okay, so when cosine theta is equal to 1, it means that A and B have the very similar or the same direction, okay, or the same orientation. Number three, when theta is pi, hey, this is 0 degree, and this is 180 degree, which is pi. Okay, 180 degree. What does this mean? Cosine pi. What is cosine pi? It is -1. So when cosine pi is -1, then the angle between these and these are 180. So what happens to their orientation? What happens? There are only two different opposite, the opposite direction. This direction and this direction. Opposite. Understand? So the tool is pretty okay, all right? Okay, but either A or C, either A or C means that A and B have a strong linear association. Linear. They are close to a line. And also, this is also a very strong linear relation. Linear, okay, because it forms a line. The two vectors form a line, although oppositely. Okay. Okay, what happens to be when their angle and when the angle between the two vectors become pi over 2, then the two vectors A and B are getting perpendicular. Okay, this is called perpendicular, 90 degrees. Okay, good. Understand? Okay, and or in mathematics, it's called orthogonal. Orthogonal. It means they have no relation, linear relation. Okay, then cosine theta. Okay. So when A and B are orthogonal, then their inner product, the aperture inner product is 0. It means A and B are orthogonal. Okay, no relation, no linear relation. All right? And my friend told me that he and his wife are getting orthogonal. No relation. Right? Orthogonal. That's a joke. Okay. You go your way, and he goes his way, and his wife goes her own way. Okay? That means orthogonal. No direction. No. The same direction or the opposite. No. That's perpendicular. Orthogonal direction of 90 degrees. No relation. Okay? Okay. And so when the cosine theta is 1 or cosine theta is 1, they have a similarity in their orientation. And when cosine theta is 0, no relation. Okay? When cosine pi equal very close to -1, they have opposite directions. Okay? So cosine theta is the measure of the similarity between two vectors, A and B, where A and the theta is the angle between A and B. Okay? And measure. Okay. So let me go to the next slide. Here. Yeah. Now suppose that we have a sample. Here the sample. X1, Y1, X2, Y2, all the way to X and Y. We have and here the observation. Xi, Yi, or I from 1 to n. Okay. Consider But now this is not a vector we wanted to study. Well, with the vectors we wanted to study is the dividend vector. X1 minus X bar. X2 minus X bar. Xn minus X bar, okay? And what about B? B is Y1 minus Y bar, Y2 minus Y bar, Yn minus Y bar. So a measure of the similarity of the orientation of the two vectors A and B is thus given by, hey, suppose that the angle between A and B is theta. Here. Yeah, next slide. So, cosine theta, when A is xi minus x bar, B is yi minus y bar, and both are n-dimensional, then cosine theta is now calculated by, hey, the inner product of xi minus x bar, yi minus y bar, and the length of A and B. So what is the length? And this is A1 squared plus A2 squared plus all the way to AN squared. Okay? So this is the length or the norm of A, and this is the norm of B. Okay? Is the test. So this formula can be used to measure the orientation of X vector and Y vector. Okay? So in statistics, we call it the sample correlation coefficient of X variable and Y variable, and it's denoted by R into R sub XY, henceforth. Henceforth means from now on. From now, we call it the sample correlation coefficient. All right? Any question? Okay, if you don't have any questions, so let us keep going. Don't look at the cell phone all the time. Look at the screen. So because cosine theta is always a value between a number between -1 and +1. Okay, so the sample correlation or cosine theta must lie between -1 and +1. So the sample correlation coefficient is always between -1 and +1. Hey, this is going to appear in your final exam. Right? Absolutely. You will see it. And you have to answer it in the mid-month final exam. And which I am now recently preparing. Any question? If you don't have any question, so I will keep going. It is a paired observation, and hopefully we have an paired observation. Okay, and what is this? What is this? What is this part called in statistics? Raise your hand if you know the answer. What is it? What part is it? Yes, very good. Yeah, good. Scatter plot. Okay, scatter plot. So we are. So now we plot the n paired observation in the plot, and to compare their singularity in the orientation of X, and here This is the orientation in X, and this is the orientation in Y. So what do you see in the upper left diagram? Upper left quadrant. They have similar orientation, right? Very similar. That's what we feel visually. Okay. That is what it appears visually. But we need a number to assess the similarity in their orientation. So what is hey, and then when I use after I use Microsoft Excel, I obtain their correlation coefficient, which is 0.96817, which is very close to 1. This means that they have a strong relation for movement. And you goes up, you go up, I go up. You go down, I go down. And that's called movement. Understand? Hey, you remember the campaign? The movie? You jump, I jump. Do you remember the movie? Titanic. You jump, I jump. Okay, that's called movement. They move together. Same direction. Why? Because cosine theta or the sample correlation coefficient is 0.9617, which is very close to 1. Okay, they have strongly similar orientation, okay, between X and Y. So what about this? The relation is also strong because it is close to minus 0.92215. Listen, the linear orientation is also very strong. Although the sample correlation coefficient is minus 0.922, which is very close to minus 1. Hey, X and Y also have very strong linear relation, but they have opposite direction. Okay, they have opposite orientation, but the linear relation is also still very strong, no matter positive or negative. Okay, all you need to care about is the number after the minus sign or positive sign. Okay, so the linear association, linear relation is still very strong. Hey, upper left and lower right. Okay, bottom right. And what about it? What about this? What about this? No relation, because very close to 0.010942, which is very close to 0. And you see no association between X and Y. Hey, you look at this. When S goes up, goes to the right, when S goes to the right, Y either goes up or goes down. Bipolar. And you mean bipolar? Hey, when S goes to the right, hey, you see Y either goes up or sometimes goes down. I don't see any similarity in their orientations. Understand? And this is why the sample correlation coefficient is 0. Okay, then the angle between X vector and Y vector are very close to 90 degrees, orthogonal. Orthogonal. Understand? And what about this? appear to be some similarity in their orientation, but not so strong. The linear relation between x and y, is not so strong as this one or this. Understand? Linear association, linear relation between x and y are somewhat moderate, not so strong. Moderate means y. Okay, understand? So, and you see that the correlation coefficient is positive. This means that they are linearly and constantly correlated, but not so strong. We can only say mild or moderate linear association between x and y. Okay, and it is only to appear in a final exam. I will give you 4 o'clock without this number. Without identifying their the correlation coefficient. But I will give you 4 or 5 simple correlation coefficient below the fourth part. And I will want you to identify these graphs to identify the correlation coefficient that corresponds to this part. And I will also let you identify the correlation coefficient that corresponds to this part, which is no relation. Okay, I will have you identify the correlation coefficient that corresponds to this part. A mild linear relation. And I will identify this part, which is the simple correlation coefficient. I will have you identify or pick up the simple correlation coefficient that corresponds to this one, which appear to have strong but negative linear association between x and y. Hey, strong linear association, although negative. And this is strong also. There is also strong linear association between x and y. Positive. Okay? Any question? Any question? If you don't have any question, then I will keep going. Yeah. And this is the perfect. This is perfect. And this is in this diagram, the simple correlation coefficient is -1, okay, negatively close. Okay, and positively close. And so the perfect linear relation, okay, the center, the very center direction is reactive one. Okay, so this is perfect linear, and this is also perfect linear, but negatively related. Okay, so RXY is the measure of the strength, hey, linear association between x and y. Okay, what happened to the statistic error? Later, I had wiped them off. Any question? Any question? If you don't have any question, then I will keep going. Between x and y. Yeah. X and y. Okay. loosely linear relation or strongly linear relation. I think it's a little strongly linear relation. Understand? And what about the absence? Number of absence and the final. Strongly linear relation. In my grading policy, using based on my grading policy, your absence and your final grade will be very linear, strongly linear related, but negative. That's all negative. The more time you are absent, the lower grade you will. Understand? Is that so? So that's the simple correlation coefficient will be very close to 1. Right? Minus 1. Okay? So, hey, keep this in mind. This is going to appear in the true and false question in the final exam. RSY is a measure of the strength of the linear constellation between X and Y. True or false? True or false? So here. Why? True or false? Yeah. The measure of the strength of linear association between X and Y. Okay, let's keep going. Okay. And hey, what we have learned, what we have seen before, is the sample correlation coefficient, which is beta. Why is beta? Because it is calculated based on observation. It is not a true population correlation coefficient. And now this is the true population correlation coefficient, and which is denoted by rho xy. Hey, this is the real one, but it's over that one. If you know it, then you don't have to sit here and learn the statistic. Okay? You don't have to be here. If you know the value of if you know the true value of our rho xy. Okay, this is the true one, but always unknown. And we are using statistical method, statistical theory to approximate, to get an estimate of this the true one. Okay, so what is the formula of the true correlation coefficient? Hey, this is also between -1 and +1. Okay, -1, +1. Okay, the true formula, the formula for the true population correlation coefficient is given by, hey, what is that? Raise your hand if you know the answer. This is called covariance. Covariance. Okay. CO means always means together. Okay, together. So move covariance, and this is the standard deviation of X, and this is the standard deviation of Y. And this is the true one, but which is always unknown, but the worry. Why? Because based on by the law of large number. Law of large number. RHY is very close to rho xy. And the big one, and this is the big one, and this is the true one. Okay, will be very close if your sample size is big enough or large sample size. Okay, if the sample size is big enough, then the fake one and the true one, and then the real will be very. By what? By the law of large numbers. I can prove it because I'm a professor of statistics. Okay, I can prove it.
Okay, any question? If you don't have any question, then so
if rho, the true value of rho is get that x and y have no linear relation. For example, hey, x and y have no linear relation. For example, hey, this kind of the mean number of change of a company's employees. Then y is the annual growth rate of a company's revenue. Hey, number of change of its employee has much to do with the company's revenue. It's ridiculous. Hey, does the number of gym you have much to do with the final score of your final statistical score? The number of gym, your final grade for the statistic score? No. No relation. And so likewise, like before, hey, we may be interested in testing whether, hey, this is true or this is true. If your hypothesis setting is this one, hey, smaller or equal to 0 or is bigger than 0. When you take this conclusion, then it means that you are concluding that their relations are positive. It's positive. Okay? So, and on the other hand, if you're testing the two hypotheses, the hypothesis setting is this one, and you take this conclusion, then you take this assumption to conclude that this is true, then you are concluding that the relation between x and y are negative, like axis and the final negatively related. Understand? And then maybe you wanted to your hypothesis that is 0 or not 0, and this will be a future test. Okay. It is so much like what we have done before. Okay, so and if you wanted to test any one of them, you always need a test. You need a device. So what is the device? The device in statistics is called test. Test statistic. Okay, and the test statistic will be, this is the one, and the test statistic is always has much to do with the fake one. But you always use the fake one to test the true one. That's what statistician does always. Okay? Okay, hey. So we are testing the true one. But we don't know the true value, so we use the fake. Okay, what is the fake one? Fake one is RXY, little r sub
xy. Any question? Okay. So
this is the test statistic. Okay, this is the formula in your test book. I will give you the page number later. Hey. This is the fake one. This is also the fake one. And this is the sample size. The number of paired observation. Okay? And we can use this to test any one of this. Okay? We use the big one. Hey, remember, it's the big one is the previous slide. The big one to test the real one. Understand?
and
Likewise, it's very much the same as the what we had done before. Three rejection regions. right hand test, left hand test, and two-tailed test. Okay? Okay? And the rejection region, hey, the inequality, the direction of the inequality, hey, bigger is the same as this inequality, bigger. Oh, I missed the H0 and H1. Okay?
Yeah. I forgot. Sorry. H0 and H1. Hey. Don't forget. H0 here, H1 here, H0 here, H1 here, H0 here, and H1 here. Okay, so we have we draw conclusion about the real one based on the fake one. And this is my formula, and you can also use, hey, you can put this term in a, you can put this term in the denominator, but you have to switch, okay, the two terms. Here. Yeah. Okay, either use this one or this one. Yeah, and hey, okay, now we know we will use this to test the true one, the value of rho, okay? But to make it to perform a test, we need the distribution and the table. We need a table. So what table should we go to? Key table. Why? Because this guy is distributed, is a random variable, and a random variable has a distribution, and the distribution of this random variable is T distribution with a degree of freedom and -2. All right. Okay. And who discovered this relation, the distribution? Who discovered? It is called the man. The statistician is called Carl Pearson. Is it Carl Pearson? Is Pearson? Oh yeah, Carl Pearson is this guy. Right, and this guy. Carl Pearson, born in London. Okay, a very very successful, very smart and successful and resourceful statistician. Okay. Okay. And now let us look at the example. Example 10-4. Sorry, I have to wipe off later. Okay. There are 7 observations, which are, and each observation is paired. Okay, paired observation. All right. I have to wipe this off. Otherwise, they will cut my salary. So you don't have any evidence of Chinese language. times of absence have you done? How many absence? How many times of absence? 2 times. Why? And what is the final grade? 86. And now what about the third student? He must be very busy or lazy. How many times he or she was absent? 50 times. That's so many. That's just people. 50 times. And what is his grade? 43. No wonder he or she deserves it. That's so low. Okay? And the fourth is 9 times, and the final grade for him or she or her is 74. He's also busy. Okay? 12. He or she had been absent for 12 times. And what is the grade? 58. He or she deserves it. Okay. Okay, 5 times 90, and 8 times 78. Okay. And we needed to obtain the fake correlation coefficient. What is the formula? The formula is this one. The fake is this one. Okay. This one. And this formula. Okay. But in the final exam, I will give you the numbers for this. I will give you numbers for the upper terms, the uppermost term there. I'm not giving you the value or the value for it. I'm giving you the numbers alternatively. The other way. Okay. 10-minute break. I have to redo myself. So I will log in again when I come back. I mean the team. So what you will see in the final exam is the value for this formula. You have to obtain this cell. Why? Because there are only 7 numbers. And you will have to obtain this all by yourself. Okay? And divided by 7, you will have X bar. Divided by 7, then you will have Y bar. Okay? So I will give you some, and you have to do some of them on your own. Okay? Here. So you have to obtain this and this and this. And then once you obtain that, you can put them into the formula. And you will see that the correlation coefficient is sample correlation coefficient is minus 0.94, which is very close to -1. Hey, what is their relation? Opposite direction. Okay, opposite. And the strength. What about the strength of theirs in linear association? Strong, very strong. Okay, because it is very close to -1. Minus means it goes in the opposite direction. Okay, so the more you are absent, the lower grade you get. Understand? Okay, this also applies to this one. Okay, now, we are interested in testing this hypothesis. In testing the two hypotheses here. This one. Which one? The final grade you get are negative, only negative. Understand? And I wanted to conclude that. And what is the test statistics? The test statistics here is this one. Yep. The P R times the square root of n minus 2 divided by 1 minus r squared, where r is the sample correlation coefficient, okay, which is negative 0.944 in this example. And so let us put it in. So again, the t-value, you see that it is minus 6.9398, which is far smaller than minus value of t sub 7 minus 2, 0.05. Understand? So what is the value? It is minus 2.015. Okay? The 3 of 3. You go to the table, you will find it. Okay? And now here it is our hypothesis setting. And now what is the action we take? What is the decision we make? The decision we make is to reject the null hypothesis in favor of the alternative hypothesis x1 at the level of alpha equals 0.05, and it means, and you can also conclude that the absences and the final grades are negatively correlated. The absence and the grade has a strong and negative linear relation. I will let you answer this question. I will want to see this answer in your final exam. Okay? Any questions? And what is the decision we take? We take this one. We take this assumption. Okay? And we reject this one. Why? Because the p-value is so significant. The evidence is strong enough. Okay. Far smaller than the critical value. Far smaller than the critical value. Understand? Any question? Do we have any question? If you don't have any question, then I will keep going. This is the p-value. T-test. We use. I think it is also used in your textbook. Please go to the textbook. The textbook. Yeah. Please go to page 549. Page 549. What is the table you test with? Also T. Also, the same as mine. It is the same as what we had been. The T table. We go to the T table. Right? T table. Okay, and look at it. This is T. But there is another method, which is exactly each student is exactly the same results as the T test and alternative method. This method is exactly the same. Exactly the same. Okay, as this one here. And the test is derived by it's obtained by the power Pearson, by this one. And it provided a table called Pearson table, not T table. But don't worry, two methods, these two exactly the same. And the two test procedures are equivalent. You know, equivalent in English, equivalent. Equivalent means same thing. Although in different form. Okay, same result. Okay, same decision, same results, and same spirit. Although they appear in different forms. And here we use T table, but our students use these old table. But don't worry, two methods are exactly the same. Here. An alternative method is to compare just to compare the R is the statistic RXY and here this one RXY. Sample correlation coefficient and a critical value from the Pearson table. Hey, what we compare here is the statistics and the critical value from T table. But in the Pearson, we just compare RXY and Pearson critical value. Okay. Any question? If you don't have any question, then I will demonstrate. Here. Critical value of Pearson correlation coefficient. Hey, this table here, the column here is the sample size. Sample size, just compare. Hey, just go to 7 because the sample size is 7. And this is not T table. Okay, not T table. It's Pearson table. Okay, and what is the value of your R? The R is minus 0.94. And what is the Pearson's critical value with sample size 7? Okay, 0.754. So it is first also smaller than, so that's smaller than. Hey, because it is a less than 10. So you just add a minus sign here by yourself. You just add a minus sign by yourself because it is a left tail test. Okay. Sorry. Minus. So conclusion is also the same as what we have drew before. What we have drawn. And our conclusion here, based on this table, this critical value, these two reject the null hypothesis in favor of H1 at alpha equal 0.058. This table is exclusively for these alpha value, for this level of significance, 0.05. Okay. Is there a table for other values of the level of significance? Yes, we will see later. But I don't want it to make confusion. I don't want you to get confused because the table is a little different from this one. This is also the table, and the table can be used for our value of alpha. Okay, alpha equal 0.1, 0.1, 0.05, 0.02, 0.01. Okay, and this is 754. But here it is 5. Why? Because hey, it is the degree of freedom. But in the previous table, it is the sample size. Now it is the degree of freedom, which is n minus 2. And the difference is 2. The previous table, we look for the value in this row, in 7, the row of 7. But here, the row here is for 5. Why? Because, hey, you see that? DF, not sample size. Okay? So DF 5, which is equivalent to sample size 7 in the previous table. And the critical value is the same, of the same. 0.754. Okay? Understand? Okay. Why can I say out they are exactly the same? Look at it. Look at this. Any questions? Any question? If you don't have any question, then look at it. Look at this. What is the formula? R x y and n minus 2, 1 minus r x y squared. What is t? What is t? What is t? The critical value. What is the critical value? Yeah. 2.015. This is oh no, sorry. 2 point. D right here equal 2.015. Okay. And now what is the Pearson value? P equals 0.7. 0.7 what? 54. Hey. Or okay, yeah. If you put this, the critical value 0.8. If you put it in it, you will get this. If you replace 0.754 And here also 0.754. And what is this? This is 7. Then you will obtain this. And that is why I said, that is why I said the two results are exactly the same. Okay, now let me let me check it out. I don't know if it hold. Let me see. 0. Prime with a root of 5 divided by 1 minus. I don't know. What? Not the same. Sorry. Uh-oh. What happened? Not the same. Is something wrong? No, not the same. No, what happened? Uh, uh, 0.05. Oh. R squared. RXY. Why not the same? Why not the same? Not the same. Why? Here. T table. I think they should be the same. T table. Uh-oh. Hey, what happened? Hey? Oh. Uh-oh. Oh. Oh, I see. I see what's wrong. Pearson table. I know what's wrong. Hey. They are the same. Pearson table. One tail, 0.05. Oh, I know. It is 5, 8, 2. Oh, sorry. 0. Is 0.669. Not this one. I know what's wrong. 0.669. This one. 0.669. Not this one. This one. I should use this one. Yeah, this one. So 0.669 here. Not this one. Not this one. 0.669. 0. It is minus 0.944. Far smaller than minus 0.669. Hey, this is the value you need. This one. Because hey, one tail test, 0.05 here. One tail, because we are performing the left tail test. So it is 0.05. And now this is 7 minus 2. So you go to 5. So you got it. 669. Okay. So and a 669 here. What happened? Okay. Far smaller. And this is RXY. And it's far smaller than this one. Okay. And I said 0.669. Right? And you will see the other thing. If you use 0.669 here, and then 7 here, then you will obtain this. So two tests are equivalent. Let me verify. Hey, try it. No, not it. 0.669. Hey, they are the same. 0.669. Try it. I think you will be the same. You're very close to 2.015. Okay. 5 divided by the 1 minus 0.669 squared. Yeah, the same. Very close. It's very close. There are discrepancy, but very close. You see this? When you put 0.669 here, it is 2.01265, which is very close. In fact, they are exactly the same. And let me put this in. Okay. two tests are exactly the same. Exactly the same. Because, okay, p value exactly the same. This is the critical value from Pearson table. And this is the critical value from T table. Okay, for example, 0.669 times 7 minus 2 and 1 minus 0.669 square is what? What is it? 2.01, okay, which is very close to 2.015. Yeah, 15. Okay, from T table. And this is from Pearson's table. Okay. Any question? Do you have any question? Any question? If you don't have any question, then I will keep going, and we are going to the next. We are going to the next subsection. Okay. It's called the title of the next subsection is called linear regression. Let me okay. In this subsection, there are also two variables x and y, and we are going to explore the linear relation between x and y, but in a different way. Okay. And let x be the mean years of the schooling of the employees of a company. Okay. in years of its work, education. How good is the education of this company's employee? And why is how good, how big is the growth of the company's revenue? Then they must be very closely related. Understand? And we suspect that there is a functional relationship between x and y. Okay? Y equal f of x. Y equal f of x. Hey, you can, hey, this is the functional relationship between x and y sine x. Or can be, or it can be log x. Or it can be more complicated. X squared. Okay, or the square root of x. Or something like that. But the relation are a little complicated. Okay, and in this section, we are not adapting it. No, because why? Because it is too complicated. We want to explore. We want to assume that. We will assume that the relation is very simple. So what is the simplest functional relationship between x and y? It's linear. This relation, functional relationship, is the linear relation. A plus bx. Linear, because you will why don't you make it wider? Okay. And when it is a plus bx, b is the slope. And what is a? This is a. Okay, and what is a? A is the intercept. Intercept. This, hey, when this and this, okay, intercept, then we call A is the intercept. Okay, so this is the simplest functional form between x and y. Okay. Okay. And what is the can someone give me an example when x and y have a perfectly linear relationship? Perfect. When you observe, then when you see x here, then y is exactly on here. When x is here, then y is exactly here. Give me an example. If you can't give me this example, I will give you extra bonus. What is the example? For example, x is the temperature in Celsius. Y is the temperature in Fahrenheit. They have a perfect linear relationship. Understand? Celsius and Fahrenheit, same, but nothing. Exactly on the line. When x is here, then when it is when the temperature is x here, then it must be y here in Fahrenheit. Exactly, all of them are exactly on the line. But in theory, some of the observation do not always hit the line, not always on the line. Can be there. For example, hey, this is not what we wanted to learn in this section. What we want to learn is this relation. Something like this. Fathers. Okay, and what is this? Children type. A kid type. Child. Okay, yeah, they have a linear relationship, but not so strong. Linear related. When father at this height, hey, you may observe that the kid's height is here, or it may be here. Okay, there is no straight line past all that the pass passes through all the points in the scale plot. Okay, and when the father's height is here, hey, the kid's height will be here, or maybe here. Hey, maybe this child has better nutrition, better sleep, better leisure time. He grows happily. Understand? So that's why he grows so high. Although his father is a little short, his father is a little short, but the his child is, it's so tall. Okay? Okay. Maybe a father's height here, the kid's height is here. Oh, okay, some other example. And this is the scatter plot. Okay? And once regress. The word regress is not used personally for statistics. The word comes from regression, comes from the word regress. And the regress is not used personally for a statistic. It's usually, regress means to step back. Step back. Okay. And regress means something like step like back. And when you have this observation of father and children's height, okay, the scatter plot, and we are looking for a line that best fits this observation such that when you make a prediction, then your prediction is always a step back to the line, 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 or you can say regress to the line, regress to the line, regress to the line, step back to the line. Okay. So if you have these observations, okay, like the scatter plot here, and the purpose of linear regression is to find the line, or equivalently, find the best combination of A and B, such that the line best fits the scatter plot. The line best fit the data. Okay. Hey, when you see this, you won't like a regression line like this, or a regression line like this. Okay, the red ones are not the best fit. Okay, visually, you can judge it by your eye, just by your eye. The red line does not fit well. It fits badly. They fit badly. But this white line looks better, much better. So how to find A and the slope B such that the line is the straight line that best fits this thing. That's the purpose of linear regression. Okay. Okay, any question? If you don't have any question, then I will proceed. I will keep going. Any question? Okay. Okay. There are other example. For more example, like hey, X is the years of the schooling. Okay. Of the white collar labor. Okay. And Y is the weekly salary of a white collar labor. Okay. The more you go to school, the more you learn. That's all. Yeah, I think so. And X is the hour of absence of a student in a course. Y is the final of a student. And we suspect that there is a functional relationship between this X and Y or this X and Y. Okay? Okay. The simplest functional relationship between X and Y is the linear relation given by Y equals B mx. Or by Y because M and B is used in your textbook, where B and M are both unknown and are to be estimated based on the scalar plot. Okay, for numerical example, let X and Y be summarized as the following table. And B is the slope in this function. B is the slope, and B is the intercept, and M is the slope. Next slide. Okay. You have the scale plot, and if we wanted to find a line that fast through, fast that and the line, the pencil line is the fast fit line. Okay. So when you assume that X and Y has functional relationship. Is Y equal B plus MX. Then the purpose of linear regression is to find a combination of A and B. BM, sorry, B and M, such that the line Y equal B plus MX best fit. Hey, the best, there is a criterion for the best fit. Okay, And next week. Okay, Rocco. Rocco. Hey, ready? What happened? Hey, what happened? 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. That's it. Anyone miss that? Anyone? What is? Hey, come to me. What is your name and seat number?
680。
No, seat number. Name, just name. Seat number. Seat number. Number. You just give me your name. Names. You should know your seat number.
Please unrecorded.
What?
Please unrecorded.
Oh, unrecorded.
How much do you buy this computer source?
How much? 30,000 NT. You cannot buy a second-handed from the second-handed market. What?
What my attendance?
If you want to do it, you have to get the one who made it in the first hour. That's fair, or that's not fair enough.
I mean, the paper one, sir.
No. I mean, someone the same as you. Those the same as you. That's fair, and I cannot do it only for you.
But I.
是就是比较像，假如说那个 R 是可以用这个，反正就是或者是你可以自己本身那个组长。
没有啊，那个好像是那个 table Pearson table 抓出来的。
是说可以做，
没有，不是。
就是
table 对 table 才能比啊，比。
其实对啊。
对，直接比啊。
哦。
对。
就说 create no value 从 real 上面找出来什么，然后你再上去 R 上面
带进去，再去跟那个 T 来比是一样的。
对 T 跟 R。哦 ，OK。
对。那么 P 跟 P 跟 T 去比 ，P 跟 T 去比，然后带那个公司进去比。
我要算出 t 的 value，然后再跟 p 比。
不是算出 t 的 value， 是查出 t 的 value， 然后把那个 Pearson 的公式带进去那里，对，带到那个公式里面，对，哎，
另外一种比较好看，
啊，
另外一种是比较的一种。
哎，对啊，对啊，然后你比这个跟比那个是一样的，哎。
脑菜鸡，我还有3000块。
有点不太懂这个公式是要，它是加总前面部分减掉后面，还是说这后面
哦，那个挂号前面要挂号了，这个要挂号了。
哦，这个是挂号。
对对对。
哦，那这边也是前面这样子。
哎，对啊对啊对啊。
OK，Thank you。